Okay, so today is going to be a really short lesson since we had a quiz. Just want to kind of introduce you to identifying congruent triangles. So congruent triangles are triangles that have 3 congruent sides and 3 congruent angles. Okay, so they have to match up in all sides and places basically. So what you're going to see a lot of times is called a congruency statement. So that states that one triangle is congruent to another and identifies the corresponding parts, which we're going to talk about here in a second. So here I have triangle ABC is congruent to triangle DEF. So that is my congruency statement. Okay, so it may ask you to write one of those. It could also refer to a congruency statement talking about corresponding parts. So all corresponding angles and sides must match up. So I'm going to look at my congruency statement to know which parts are congruent from one triangle to the other. So AB on this first one is right here. How I think of this is I look at, all right, AB is the first two in our statement, so it's going to be congruent to the first 2 letters from the other statement, okay? So I would say the AB is congruent to DE, and those are segments because they're just a side here. Make sure that you remember, if we're doing that, then that means we mark they're congruent with the little line on the segment. All right, then I would go on to my next side. So I would say that BC, which is the second 2, would be congruent to EF, so the second 2 from the other triangle. And lastly, AC is the first one and the last one. So it's going to be congruent to DF. You could say these the other way and that would still be correct, like AB congruent to ED, but you really want to try to match it up. Like A is the first one, D is the first one, B was the second one, E was the second one. Okay, just to kind of keep things in line. So we have our 3 congruent sides here that we named. Now you want to think about all the congruent angles. And again, do this the same way by looking at that statement. So angle A would correspond with angle D, and they have marked that A to D. All right, then we would do angle B as the second, so it's going to be congruent to angle E. Keep in mind when you are marking them on the triangles, these now get 2 lines. So B and E would get 2 because they're congruent to each other, but not to A and D. So we want to clarify that difference by putting the 1 on those and then the 2 on B and E. Okay, so make sure you kind of add to that as you go. And lastly, C, angle C, will be congruent. So it's the last letter in our statement, so it'll be congruent to angle F. And then I will mark that one with 3 lines. I don't think I touched on that with the sides or the segments, so same thing with congruent sides or segments. So A and B, E and D got 1, and then they labeled BC congruent to FE with 2, and then AC to FD with 3. So you can just kind of keep adding to label as much as you need. All right. Now, we're going to use this phrase quite a bit. So CPCTC, this means corresponding parts, which is like what we just talked about. So like AB was corresponding to DE, angle A was corresponding to D, etc. Are congruent. So if they're already telling me the ABC is congruent to DEF, so you want to think about everything this means. So what I'm really wanting you to do here is, there we go, is this. Identify all of this on your own. So I will start you off with one of each and then I will have you try them. So I'm going to put the sides here and the angles over here. So I would say segment A or side AB is congruent to DE. And then mark it on your triangles. And for the angles, I could start off and say angle A is congruent to angle D. And again, I knew this because they were the first letter in each triangle in our congruency statement. All right, and I would mark that over here. Angle 1 gets one swoop, or angle A gets one swoop. Angle D gets one swoop. All right, so you guys take a pause and try to name the other sets of congruent sides and angles. Okay, hopefully you're just checking your answer now. I labeled, I finished off the sides and angles, so take a second and just look and make sure that you got all of these correct. Okay, and then I wanted to touch on one thing and show you an error here. So I marked the angle A and angle D are congruent, and then if I did B and E like this, that would tell me that they're also congruent to A and D because they only have the one line for the little swoop. So make sure that you put 2 there, 2 there, and then for C and F, I will do 1, 2, 3, 1, 2, 3. I am going to add one thing to this on the angles. We only used one letter on these because there wasn't, like this point didn't have multiple angles at it. Like if it were like this, then it would. So remember that you can also use 3 letters. So angle A could also, I'll just write these to the side. So angle A could also be written angle BAC because it would go here, here, here. Will be congruent to angle EDF. For B, I could say angle ABC is congruent to angle DEF, and then for C and F, I could have said angle BCA is congruent to angle EFD. So using 3 letters, and there will be some instances where we have to do that, so just keep in mind. If you can only use one, like we could here, then awesome. If not, make sure you're knowing how to name with 3 as well. Okay, so some things to keep in mind when we're looking at congruent triangles or trying to prove congruent triangles is we can still get congruent parts from things that we have learned beforehand, okay? So one option for this is parallel lines. So parallel lines, so remember that is marked by the little arrows on the lines, create congruent angles when there are alternate interior angles, alternate exterior angles, or corresponding angles, okay? So in this case, I could do angle JDA, it's right there, and is congruent to angle, and I could name that a couple ways. I could say MEA, that would work. So I'm going here, 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 like that. Or you could have went the other way, like AEM. So I know those two are congruent because they are alternate interior angles. So I could have used one of these others as well, so keep an eye out for those two. Vertical angles are created by 2 intersecting lines and are congruent. So you want to think kind of like opposite sides here. They're not going to be right beside each other. So our intersecting lines are right here and right here. Darken that up here. So there and there, intersecting lines. Okay, and this one does form 2 triangles. So I want to think those opposite angles here, so here and here, are vertical angles in this case. So I'm going to say angle ACB, that would be this one, is congruent to angle ECD, which would be this one, because they are vertical angles. So anytime they make that like X and they're across from each other, these two here would also be congruent, but those aren't within the triangle in this situation, so they wouldn't really be helpful to us. All right, and last thing, common sides. So if two figures share a side, those two sides from each are congruent, because it's really kind of like the reflexive property, because DB right here, those two triangles have that in common, all right? They both have DB used to make up the triangle, okay? Because I have this top triangle here and the bottom one here. So all I'm really thinking is in this image DB, you could either say, you can just say is congruent to DB. So reflexive means equal to itself. Okay, so on these examples, it says mark the congruent sides and angles on the figure, use symbols. So I mean like mark it with, like your little line for congruent sides or your swoop for congruent angles, and explain your reasoning. So by that I mean tell how you knew that, which thing that we talked about up here maybe would make that work. So for number 1, the first thing that stands out to me is these angles in the middle would be vertical angles, all right? So to name those, I would say angle ACB is congruent to angle ECD. And I'm just going to put in parentheses because they are vertical angles. Vertical angles are congruent. All right, something I would not want you to say there. Don't call this just angle C, because there are 4 angles in that section. So I can't just say this, because that wouldn't really be helping me out with connecting those two triangles, because this is a triangle in this image and so is this. So I'm trying to connect those two. All right. That's really all we have from this one. It looks like these two lines are parallel, but they don't specifically tell us that, so I can't assume, okay? So that's all we can know for that one. Erase that. Okay, and let's look now, number 2. So number 2 does have a set of parallel lines, so right here and right here, and we also have intersecting lines here and here. So my intersecting lines create vertical angles, so I could again say angle ACB is congruent to angle DCE. I did it the other way this time from that one, but it's still the same angle because they are vertical angles. All right, and since I have these parallel lines, it's kind of like I have 2 transversals here. I have this line cutting through as a transversal, so that means I can say that angle ABC right here, remember I need to put 2 lines on it, is congruent. It's alternate interior, so remember inside of these 2 lines, the opposite sides of the transversal, which is that line, will be congruent to angle DEC. And those are alternate interior angles. And it looks like we actually have one more on this. So I could lastly say, don't have room, I'm going to try to squeeze this in, the angle BAC, so this one, is congruent to angle EDC. And that is actually the same reason. They are alternate interior angles. All right, 3. So 3 really doesn't have any intersecting lines, so we can't have vertical angles, and it doesn't have any parallel lines, so we can't use any angle relationships from those, but it does have HF that's in both of the triangles, okay? So I can use that. I can say that segment HF is congruent to segment HF, and the reason would be it is a common side, meaning they have it in common or they share it. And that is all I'll be able to say in this case. So make sure you can recognize those common sides. Okay, 4 through 6, so we're trying to identify what they've already marked. So we talked about we can pick out congruent angles or sides from parallel line relationships, vertical angles, or common sides. But another thing maybe there is they're just going to simply mark it, okay? So if it's a segment, we're looking for that little dash on the line. So that tells me that segment LM is congruent to segment MN. And I knew that, or my explanation would be because they were marked congruent. And that would be all for that one. Okay, on number 5, they have marked 2 sets of parallel lines. So we have that QR is parallel to ST. So I'm going to look at that first. So if those two are parallel, RS is like the transversal line. So before, when we had that, it would like continue on. Now it just kind of stops since it's a side of that other triangle. So RS is the transversal to QR and ST. All right, that makes us be able to use, if those are parallel, we can use either alternate interior angles, alternate exterior, or corresponding to show congruent angles. Okay, so in this case, we have, we could use QRS here. So angle QRS is congruent to angle TSR, okay? And those would be alternate interior angles because they are within those two parallel lines, the QR and ST lines, and they're on opposite or alternate sides of the transversal, which is RS in this case. All right, so that's the first set we have there. All right, I'm going to erase this off of here kind of to show you. So this is one of those where it has 2 sets of parallels. It has that one that we just dealt with, and then it also has, hold on, it's running a little slow, RS and TU. And I know those because they had the double arrows. So when I look at those, I'm going to go ahead and remark that congruent angle that we marked first. When you look at those, ST is actually the transversal line, or that cut through line there, okay? So for that case, I can say that angle UTS, so that one, is congruent to angle oops, I forgot my angle sign, TSR, which is the one that we already marked right here, okay? So that is TSR. Remember, it's really important that you use the 3 letters on that one because there's really like 3 angles all by S. There's this one and this one and this one. So make sure that you're clarifying by using the 3 letters which one you're talking about. All right, so it's important that I tied those two, all 3 of those angles together, because this one in the middle here really wasn't in either of our triangles, so it didn't really help us out in being able to identify 2 parts of the triangles. But then when we tied this S to use to connect those other 2, that did make a difference. Again, on this one, those are alternate interior. Forgot to say that. Okay, I'm going to clear this off again, but leave the angles here. Nope, didn't get that one. Okay, so we have that one congruent to that one and to this one, which that S one there in the middle I don't really need, but I can use it. Okay, so I'm going to go ahead and look for another, see if there's anything else we have. So we've dealt with all of our alternate interiors. Doesn't really look like we have any exterior angles in this situation, but I could look at this other set. Oops, go back to this set of RS and TU being parallel, and I could use this bottom segment down here as the transversal. If I do that, I can then say that this angle, which is TUS or TUQ, either would actually work, is congruent to, and I want you to actually take a pause and try to name the other angle it is congruent to. Okay, hopefully you are checking and that you got it is congruent to angle RSQ. So those would be corresponding angles, which are congruent. Okay, we have one last set here. So again, if I look now at QR is congruent, or sorry, not congruent, parallel to ST, and I still use this bottom segment as my cut through line, my transversal, then I can name one more set of congruent angles. Oh, I meant to mark that as a double to show they're congruent to each other, but not to those first ones. So this one, I'm going to say, I'll start you off again, then have you try it. So I would say RQS, I'm going to put 3 swoops this time, is congruent to angle, and then see if you can name the other one, the other corresponding angle again. Okay, hopefully you're checking your answer, and you should have either angle TSU or UST. I could read it backwards as well. Okay, so now we've proven that all 3 angles in both of those triangles are congruent. Okay, last one here, number 6. So we already have something that is shown on here, so I'm going to simply state that. These 2 lines tell us that segment WX is congruent to segment XZ. Okay, and the other one we can use is they share this common side. Oh, on that one I'm just going to put that was marked. So it means our symbols have there. So I can say XY is congruent to XY because it is a common side, meaning they have it in common. All right, and that's really all we'll be able to identify from that one, okay? So that is all for today. Your homework for this lesson is actually just a Canvas quiz. It's really short. You're trying to identify the corresponding angles, sides, and then find some of those missing components and numbers there. So make sure you complete that. Feel free to go back and watch this on anything that you need, and have a good day.